let's talk about some consequences of the mean value theorem. So as a reminder, here's a statement of the mean value theorem. One of the things that it can tell us is that if we have a function that has derivative 0, exactly equal to 0 for all x in some interval, it's a constant function. F of x is equal to c for some constant c. This is actually going to be something we can prove pretty easily. So for a proof, if we take a1 and b1 as points in the interval a to b, just pick them to be different, by the mean value theorem, there is some point c between a1 and b1 such that, so let's remember what the mean value theorem says, this is true. F prime of c is equal to f of b1 minus f of a1 over b1 minus a1. But what is f prime of c? By the assumption this is equal to 0. And so if this is equal to 0, well, the numerator must be equal to 0. So what do we conclude? We conclude that f of b1 minus f of a1 is equal to 0, or f of b1 is equal to f of a1. Okay, so that is one quick little consequence of the mean value theorem. That's starting to point us in the direction of where we're going to go for the rest of the section. Another thing that we can get has to do with signs of the derivative. So what does the sign of the derivative, whether the derivative is positive or negative, what does that tell us about how the function behaves? So here is a theorem that tells us how our function behaves. If f prime of x is strictly positive, greater than 0, for all x between a and b, then f is increasing on the interval from a to b. If f prime of x is less than 0 for x between a and b, then f is decreasing on the interval a to b. And so this is something that, again, we can prove using the mean value theorem without too much difficulty. So let's suppose that f prime of x is positive for all x in the interval a to b. So what does mean value theorem tell us? So let us pick 2 points x1 and x2 in our interval a to b. By the mean value theorem, there is c between x1 and x2 such that f prime of c is equal to f of x2 minus f of x1 all over x2 minus x1. So let's talk about, we can't just say this is 0, and we're done like we did on the previous little corollary do, but we can talk about signs here. So f prime of x is positive, so this is positive. x2 minus x1, we're assuming x1 is less than x2. This is positive. So how to finish this off? We see here f of x2 minus f of x1, that must also be positive. In other words, this gives us that f of x2 is bigger than f of x1, which is allowing us to conclude that we have an increasing function. So in this case, I'm only going to do the f prime of x positive case. You can fill in the details for yourself. everything is very analogous in terms of the case where f prime of x is negative. Let's end this video with a quick example to talk about f of x is equal to the natural log of x. And so f prime of x is equal to 1 over x. The domain here is, of course, strictly positive numbers. So we see here, because the derivative is always positive, f of x is an increasing function on its domain. So as a reminder, what does the graph of f of x look like? Something like this. It's always going to be increasing, which matches the information that we get from the derivative.